Ah, let the printer begin. I just sent the command to start it. It's going to take a second. Um, I just put on an XT30 there because I had an incident where the wires got ripped out. This thing actually ran over a mouse, and it was pretty gross. I'm at the building. This isn't my house or anything. This is like an industrial warehouse. It's not even really heated. It's 52 degrees in here, and that's about as warm as it'll get. But this does not care. Um, the bed is capable of 800 watts. I mean, it's sitting at. My lens is dirty. There we go. We're sitting at what 50 degrees with 225 set on the hot end. I'm pretty sure I clicked print. I didn't click print. Ah, crap! I forgot to click print. There we go. Anyways, this thing is pretty much all web controlled. I don't ever mess with the SD printing or anything like that. It's all death and damnation all through Octoprint. There's a Pi 3 right here. All right, printer, get your shit together. Let's go. Look down there. There's little feet, little cups. That bed can accelerate so hard. I've launched this thing off the desk before. Quick home for the homies. Gonna hold that Z. Oh, look, it's right on the mark in the center. Now for the hard part. I could run this faster, but more or less, not Octoprint. Marlin can't keep up with this thing if it goes too fast on the old bed leveling here. So this takes a minute. It does 16 points, 4x4. I mean, we're talking a 20 inch by 20 inch by 20 inch build area, 500 by 500 millimeters. There's the rails. Ball screw on the y-axis. I had to beef this guy up. I've sheared the motor mount in half and broke this off in my acceleration test one day. There's the Y motor mount, and it's a giant ass in stop switch. Again, industrial bits. These motors are 75 watts in this guy. The motor controllers are here and here. Got X on the top, Y on the bottom. There's X. This is my X board. This is basically a junction between everything. Makes working on it easy. These unplug. I like easy. I like connectors like this. So I don't have to run that wire through the damn wire channel again. You know, just everything, even the motor connectors right there. Keeps it simple, right? This thing has a speed, which it has a harmonic, and unfortunately, that's the speed I chose for the x-axis in this operation. But who cares? You see the box frame. I made the back section a box, so this is very stiff now. I don't have wiggly wobbly BS going on no more. Now she's printing. First layer goes slow, about 40 millimeters a second. Because you don't gotta rush it to start it. I think. Hold on. She's laying down. Just took a second to get started. I like to watch it move. This is not move like a 3D printer. This moves like an industrial CNC machine. Ah, there's that harmonic. Damn it. Anyways, this moves like a CNC machine, not a 3D printer. This bed is solid. There's no adjustments under here for, you see the big aluminum parts there. Sorry. M6 bolts. It's mounted solid to the rails. Um, there's no need for any adjustment. It all does it when it does its bed leveling. It squares up the X each Z motor is independent of the other, so it makes sure that this is level, and then it does its 16-point touch off and just starts printing. The I don't want any manual adjust. Why have it's a machine, right? Why does a machine require manual adjustment? That's not how a machine should operate. There is no manual adjustment because it's completely unnecessary. Let it do it its damn self. Um, it's got a smart filament sensor, so this can sense filament stops for any reason. It'll pause itself and wait, be it a jam or breakage or just running out. Uh, Again, automatic. There's no reason to check it to see is there enough filament for this job. I don't know. It'll print the job until it runs out. If it's got enough, it's got enough. If it doesn't, well, it'll just wait for you to feed it some more. There's our spool over here. This is the horizontal spool holder. This spool holder was intended for these big 3 kilogram rolls. Um, you could just swap it by moving the tube here over to this one. Again, there's no sensors up here because it's all done right here. Yeah, there's its camera for the live feed. I'm going to go ahead and record through this first layer. It shouldn't take long. A couple of minutes here. And because this isn't like at home or anywhere I got to listen to it, I don't care how loud it is. Oh, there's the heater. What's left? It's just rip the damn wires out. Focus. Yeah, whatever. Get off the bed. It's not recommended to stick your hands in this machine either. See how fast that fast travel was? This will move quicker and much more suddenly than you will respond to it. A friend of mine got his hand almost ran over by the hot end once. He was lucky; he pulled it out like as it was coming and got away with it. So, yeah, don't put your hands in industrial machines, folks. Again, this is a lead screw. This is a ball screw, much bigger threads, right? So this is riding on ball bearings in the nut. This, it's behind there, in the back, actually has a plastic nut. Um, it reduces friction and it's long lasting. This is lubricated with silicone grease. Um, Both the rails, the ball screw, and the lead screw are all lubricated with the same silicone grease. And that also includes the X-axis screws in the back, one on each side. The frame, again, this is a CR10 S5 frame. The only thing left of it is this basic bottom frame, these rails, and this piece right here, and this piece, and the Z motor carriages, and the X carriage behind here, the metal backing of it from the original Creality design is still there. Everything else is my design. I like to use different end stop switches. You know, of course, the lead screw drive, the motor's out here, linear with the screw. This arm just supports the camera for keeping an eye on things when you log into the web interface. Everything is printed in PLA. Plenty strong. I don't know why people whine about it, but I ain't broke much except for the Y motor mount in half when I turned acceleration up to 35,000 and sent it on a 250 millimeter rampage. The giant beefy Y end stop switch only exists because it's what I had on hand. And I just used some double stick tape and stuck it down there. There's one wheel of the original wheels that rode in the groove down here still on it, and that wheel just simply hits that switch. All this is supported by the rails, the MGN 12 rails. The main electronics is in here. It's a what are you? SKR Pro runs this, and again, Raspberry Pi 3 on this side. Everything is wired. These are 10. Each one of these is a 10 conductor silicone cable. Then you got some additional wiring for the motor and the double wire. This wire is the hot end. It's also silicone. Nice soft cable. Can handle the bends all day long, all day, every day, forever. Now we're moving. This is normal print speed. Wish I could find these build sheets easier. I love me a build sheet. They do wear. This is just the aluminum underneath. There's an 80-20, a 1-inch 80-20 frame underneath here that I built. Use a scrap 80-20 with aluminum extrusion. It's not metric because I didn't have metric in hand. There's 18 bolts. And this frame is like a box with a center bar. Bolting this to the frame. The heaters are here and here. There's two. Each one of them's 400 watts, 120 volts. And on the back, it's kind of hard to see it, but where that pink wrap is the 120 volts. And on the back there is a solid state relay that's being triggered by the low voltage DC PWM signal to heat the bed. 120 volt bed heater because it lets me run a much smaller power supply. My power supply is on here is 20 amps, 24 volts. That's mainly to run the motors, electronics. The 5 volt and 12 volt rails are derived from that using, you see them there on top there. Those two voltage DC to DC converters. So everything happens at the power supply. And then we've got the main 24 volts here. 12 volts, 5 volts come in this plug. Oh, there we go. That layer's done already. But yeah, just a quick update on it. It's still alive, still runs. I don't post videos of it that often anymore because it's become so stupidly reliable and repeatable now. I just don't need to. I always struggle with the motors skipping steps and having issues, but that was solved with these closed loop industrial motors. They have encoders built in. That's why there's so many wires. They're built-in encoders, and they handle the signaling just fine using actually little boards that came from Big Tree Tech SKR converter boards meant to run external drivers like that, and yeah, they run great. Maximum speed is right about 285 millimeters a second, limited by the bed actually, and the RPM the motor can achieve. The lead screw requires twice the RPM, or the ball screw rather requires twice the RPM as the lead screw to get the same speed. So if this was still a lead screw on the Y, it could go faster, but with the amount of acceleration and just abuse that takes, it really needs a ball screw. This bed weighs right about 22 pounds. So keep that in mind. A lot of people don't consider the weight of the printer's bed when trying to make it go quicker. That's why Core XY machines are the fastest. They don't move the bed. You know, it doesn't need it. It makes a big difference with a lightweight print head and stuff. This print head's fairly lightweight. We're looking at a very small pancake motor, Bondtech direct drive E3D hot end. It's got a Creality CR touch on it, you know. But even then, with the screw drive system, the screws locked in at both ends, it's, you know, it just, look at the repeatability. I mean, that fast, layer by layer. It's nailing those screw holes. Oh, we're starting to do the install already. Done. Yeah. Anyways, this will be done in about 2.5 hours. There's a little bracket for my server to hold up a card inside, and it'll be printed in color change rainbow filament because I'm that way.